Are you currently a secondary school student? Do you want to improve your mathematics? Here's a great deal for you. Just bring a friend along to the Learn Math tuition class. You and your friend will only need to pay $50 for a whole month of tuition. Hurry and visit the link to register. This promotion is only valid for the month of November and December, after which the usual fee will be from $400 per month. In the 4 lessons, you will go through concepts that you have previously learned and prepare for next year's syllabus. Slots are limited. Sign up now and don't miss this opportunity. Are you still undecided? No worries, here's a video lesson to give you an idea of how tuition lessons at Learn Math could be like.
So over here, you will see this y equals to mx plus c equation. So this equation, I like to call this the general equation for the line. So why general equation, right? Because with this y equals to mx plus c, you can use it to find the equation of any other straight line that is not a horizontal or a vertical line. So as long as you have a typical upward sloping line, right, or a typical downward sloping line, you can use this general equation to find out the equation of the line. So over here, you have m being the gradient. You will notice that there are a few unknowns, right? Actually, four to be more specific. When you have found your m as well as your c, so these two values, you will have a specific equation of a line. So now this is a general equation. Once you have found a m and a c, right, then you will have the specific equation of the line. So let me give you an example. Let's say you manage to find m, which is the gradient, to be 2, right? And then you manage to find c, which is the y-intercept, right, to be 2 as well, right? So you have y equals to 2x plus 2. So what you have done after you found the gradient as well as the y-intercept is that you manage to change the equation of the line that you want to find from the general to the specific equation. All right. So now, let me explain a little more about how to get the gradient, this m value, and then how to get your y-intercept, your c. So gradient first. To get gradient, you have three ways, right? So over here, I've outlined these are the three ways. So start with the first way. This is your formula for finding gradient, all right? And that is given as y1 minus y2 over x1 minus x2. Okay, so what is this y1, y2, x1, x2 thing, right? So this x and y actually is one coordinate, meaning one point that you have. So imagine, right, if you are given this coordinate 3 comma 5, for example, right? So a coordinate will contain both the x value or x coordinate and a y value or the y coordinate, right? So you can call this or at least when you're using this formula, right, this is actually like your point 1. So if this coordinate is your point 1, right, isn't this value your x1 and this is your y1? So 1 is given to the name of the coordinates that's inside this point. Now, if let's say I have another point called point 2, right, and this point is given by, or it has this coordinate 7 comma 8. What is happening is that this x value I will call x2, all right, and then this y value I'll call y2, because this point now is called point 2, right? So we don't usually use point 2, but I just wanted to show you so that it kind of corresponds to your formula over here. All right, so you can also very commonly you will see maybe coordinates given as 3 comma 5, and then this point A, right, and then point B is 7 comma 8. So I'll show you with 1 and 2 first, since the formula is given as 1 and 2, and later on we can talk about, hey, if it's A, if it's B, how do I put it in the formula? All right, so over here, what this will mean is that it will look like this because, so let me just write it here, right? Because it's a little cramped at the bottom. This is my y1 and I'll put it here, right? And then I will subtract whatever y2 is. So this is y2, right? And that is 8. And then I will take x1, which is 3 here, right? And then I will subtract this 7, right? Because that is x2. So you will realize that very nicely, this is one coordinate, right? With the bottom being the x value and the top being the y value, right? So it's actually taking one coordinate, subtracting the other coordinate, where the top is the y and the bottom is the x. All right, and this 5 and 3 is one pair, as given here, one pair of coordinates, right? And the 8, the 7 and the 8 is given as another pair of coordinates here. When using this formula, that's the thing to be mindful of. Do not mix them up. What I mean, so some students may make this careless mistake of taking 5 minus 8 and then 7 minus 3. Okay, this is wrong because this is not one pair of coordinates, right? Based on what we have shown here, 3 comma 5 is one pair of coordinates of both x and y, right? And then 7 comma 8 is one pair. So we are mixing the pairs here, and then that's why this is not correct. So let's swap it back. 3 minus 7. Okay, so this is if you are if we are using this formula, right? y1 minus y2, x1 minus x2. So you will realize that it's exactly the same, right? If I use this ya minus yb over xa minus xb, or if I use y1 minus y2 over x1 minus x2. Okay, so if you're okay with this, that's how you use the formula to find gradient. All right, there are still two more ways you can find gradient. All right, so what are the other two ways? So if you have parallel lines, right? Parallel lines have the same gradient. So this is how maybe like a parallel line would look like. Or if let's say I will draw to draw it out, it's a y-axis, this is your x-axis, and you have two lines, right, that are parallel to each other. So if you have two lines that are parallel to each other, they have the same gradient, right? Because gradient is how steep these lines are, right? And you'll realize that if you are climbing this slope and you're climbing this slope, the steepness is the same, right? So how steep it is the same. So that's why gradient wise they'll be the same. So parallel lines have the same gradient. So that is number 2, right? Now number 3, or the third way to find gradient is if you have perpendicular lines.